Hey, good evening, and welcome to the fifth session of Ellipse. In this session, we will see some more properties and also some more points about the ellipse. So, if you see the last part, then we had seen the chord of ellipse, and we derived some results. We found the equation of chord of the ellipse joining two distinct points, and then we had seen that if my chord passes through the focus. So, for a comma 0, we had done. For a comma 0, we got the result as tan theta 1 by 2 into tan theta 2 by 2 is equal to e minus 1 over e plus 1. And if this chord passes through the other focus, then this ratio would be reversed. Now, in fact, we can generalize this. This would become a broad statement. Okay. So generalized form of the above theorem. So the generalized form we can give here. Generalized form would be, so let's say if I have an ellipse here and let me take a chord which is joining two points on this ellipse, and this chord, instead of just only not only passing through the focus, because we have proved the result for passing through the focus, now it just cuts the major axis at a distance of d. It cuts the major axis at a distance of d. Then we can directly prove that. Okay. So if a chord joining two distinct points on the ellipse cuts the major axis at a distance of d units at a distance of d units from the center of ellipse from the center of ellipse. And now when I'm saying my chord joining two points, that means of course I have to take the point P as a cos theta 1. So I'll be saying it will be simply a theta 1, or else better I'll name it like this, P of theta 1. So it is to be understood that I've taken the parametric points and theta 1 is the eccentric angle here. And for this one, Q, I'll be taking theta 2. So point P is basically a cos theta 1, comma, b sine theta 1. And point Q is a cos theta 2, comma, b sine theta 2. So these are my 2 points. So that means now I can prove that tan of theta 1 by 2 into tan of theta 2 by 2 is equal to d minus a over d plus a. D plus a, where this a is where length of major axis is equal to 2a. So length of major axis is equal to 2a. You can prove the result on the same lines as we have proven. Okay. We can consider. Yeah. Okay. So we can consider the same equation. This equation we can consider now, instead of considering this point passing through a comma 0, we'll now consider that this passes through d comma 0. So d over a I'll take, and then again the same story. So again by componendo dividendo, I'll be getting this result. Okay. Same result. This will be d over a instead of e over 1. So I get d minus a over d plus a. This is what we can prove. Now, coming to the next part. Okay, today's class. We'll now find the equation of chord bisected at a given point, or use the locus of midpoint of chords. Okay. So locus of midpoint of chord. This keeps on falling every time. So equation of the chord bisected at a given point. Let me take an ellipse here. Suppose this is an ellipse, and I have a chord whose midpoint is given here, say x1 comma y1. I want to find out the equation of this ellipse, equation of this chord basically. So say this is my point A and this is my point Q. A and Q. Well, that doesn't sound great. We'll take B as usual. A and B. So we want the equation of the chord AB. So we want the equation of the chord AB. Equation of the chord AB. Okay. Whose midpoint is we can consider some midpoints as C, say x1 comma y1. So let A coordinates we will assume to be say x2 y2 and B we can assume to be x3 y3. So let A x2 comma y2 and B x3 comma y3 be 2 points on the ellipse. Be 2 points on the ellipse. So now our goal is what? To get the slope. And once we got the slope, then by using slope point form we can get, because we have this point already given, we just need the slope. So since A and B lies on the ellipse. So if they are lying on the ellipse, that means they will satisfy. So this implies x2 square over A square plus y2 square over B square is equal to 1, and x3 square over A square plus y3 square over B square is also 1. So we have these two things. Now I want the slope anyhow. That means I need to get y2 minus y3 over x2 minus x3. So looking at these two equations, this gives me an idea that I should subtract these two equations. So let's do this. So I'm going to subtract. So say this is my equation 1 and this is 2. So what I'm doing now, subtracting 2 from 1 or 1 from 2, you can do depending upon your choice. Subtracting 1, select I want y2 minus y3. Okay, we'll do this only 1 from 2. So if I'm subtracting 1 from 2, so I'll be having now x3 square minus x2 square upon A square plus y3 square minus y2 square upon B square is equal to 0. That's what I get. I've subtracted this equation from this. So y3 minus y2 square over b square, and x3 square minus x2 square. 1 minus 1 is 0. Now what happens? I can just think of opening this. So x3 minus x2 into x3 plus x2. This I get this over a square, and then plus here y3 minus y2 into y3 plus y2 over b square is equal to 0. Now in the next step, we can transfer this one to that side and then write down here minus of. Now, after this, our goal is what? Our goal is to find the slope here. So slope will be y3 minus y2, y3 minus y2 over x3 minus x2. Our goal is to get this. No, so let's get y3 minus y2 over x3 minus x2. So I'll transfer this one in the denominator and remaining things to this side. So I'll be having b square into x3 plus x2 with minus followed by a square here only, and then y3 plus y2 will come here, and I'll be having y3 minus y2 over x3 minus x2. So this turns out to be the slope of AB. So since we do not have this point x2 plus x3, but we know that this C is the midpoint of A and B. So since C is the midpoint of A and B, C is the midpoint of A and B. So which means I'll be having x3 plus x2 is equal to 2x1 and y3 plus y2 is equal to 2y1. That means now I can plug in here. This will give me 2x1, and in the denominator I get 2y1 is equal to y3 minus y2 over x3 minus x2. So this is slope. So from here I get the slope MAB is equal to this 2 gets cancelled. So I get minus b square x1 over a square y1. So this is the slope of the chord AB. So therefore, equation of chord AB we can get. So equation of chord AB is So y minus y1 is equal to slope. Slope is what? This guy. So minus b square x1. So minus b square x1 over a square y1. This into x minus x1. So multiply here. So I'll be having a square y1 minus a square y1 square is equal to minus b square xx1 plus b square into x1 square. So now we'll transfer here b square xx1 plus a square y1 is equal to a square y1 plus b square x1 square. This part looks familiar. So what I'll do, I'll divide this entire thing by a square b square. So if I divide this entire thing by a square b square, then most of the things remain familiar to us. So what happens here, b square gets cancelled and I'm left with x1 over a square plus here a square gets cancelled. We get y1 over b square is equal to here a square is gone. So we get y1, which is squared, y1 square over b square plus x1 square over a square. Now if I just write down here minus 1, then this equation brings more meaning here. So this is nothing but the equation of tangent we have seen here. And this is nothing but when we plug in when we plug in the point S1, point x1, y1 into the ellipse. This is nothing but S1. So I get T is equal to S1, where T is the equation of tangent. T is the equation of tangent, and S1 is as usual power of the point here. So x1 square over a square plus y1 square over b square minus 1. So now whenever it comes to find the locus of midpoint of chords, we'll simply use the condition T is equal to S1. And in fact, this is common for ellipse. This is common for parabola, hyperbola, and all of them. T is equal to S1. And now one more point is the equation of pair of tangents. The equation of pair of tangents. So the equation of pair of tangents passing through a point P. Which means I have an ellipse here, and then there is a point here P, say x1, y1. And now from this point, there are two tangents being drawn. So I want to find the joint equation of these two tangents. So if I want the joint equation of these two tangents, this we will do without proof. And so for this thing, you can simply use the fact that this is my tangent T1 and this is my tangent T2. So we want the joint equation. So we want the joint equation of tangents. Joint equation of tangents from point P. From point P, x1, y1. That means I'll be having here S1 is equal to T square. Please be notified that this is the joint equation of pair of tangents, useful for parabola, ellipse, hyperbola, circle. It's valid for all the conics which we are going to study. Parabola, ellipse, hyperbola, circle, everywhere. S1 is equal to T square. Where what is S? S is simply the equation x square over a square plus y square over b square minus 1. And S1 would be x1 square over a square plus y1 square over b square minus 1. And tangent is x1 by a square plus y1 by b square minus 1. So this part we just need to plug in here and we get our joint equation of pair of tangents passing through a point P. This can be utilized for parabola, ellipse, hyperbola, and circle, all of them. Now, let's see some problems based on this. First problem here is this. that if the midpoint of chord of an ellipse is given to be root 2 comma 4 by 3, then the length of the chord is what? So of course, we will go ahead with the same idea. This is my ellipse here. So x square over 9 plus y square over 4 is equal to 1. So for this, we can simply write down t is equal to s1. This is the equation of chord, or you say the locus of midpoint of chords. T is equal to s1 means, of course, I'll be just writing my tangent with respect to this point. So I'll be having x1 by a square plus y1 by b square is equal to 1. Uh, is equal to, now the next point I will be writing, this is minus 1 here basically. Now this point I have to plug in here. So I get root 2 square by 9 plus 4 by 3 square by 4. So this is the equation of chord. We can even simplify further. So this 4 and 4 gets cancelled. And so I get x. So I should write out here root 2x better. So this gives me root 2x by 9 plus y over 3 is equal to this root 2 square is 2 over 9 plus this 4 square. One of the 4 gets cancelled and I get only 4 by 9. So I can write down here 3 and here also 3. So that this entire 9 is gone. So I get root 2x plus 3y is equal to 6. Now I have an ellipse here and I have to find out the point of intersection. So this point I need and this point I need. So I can apply the distance formula to get this point by putting this line into the ellipse. So we have the ellipse here, x square over 9 plus y square over 4 is equal to 1. So now we can find out y from here. So y will be what? This is 6 minus root 2x over 3. This I can plug it into the ellipse. So therefore, I get x square over 9 plus y square over, y square. So y is 6 minus root 2x square over, this will be 4 here and this will be again into 9. This is equal to 1. So we can multiply this 4 here. So 4x square here, 4 here. So this gives me basically 4x square plus 36 minus 12 root 2x minus 12 root 2x 12 root 2x 4x square plus 36 minus 12 root 2x plus this will be 2x square and is equal to 4 into 9 is again 36. So this 36 and this 36 is gone. 4 plus 2 will give me 6x square minus 12 into root 2x is equal to 0. We can take, in fact, 6x common. So I'm left with here x minus 2 root 2 is equal to 0. So from here, I get x is equal to 0 once and x is equal to 2 root 2. So when x is 0, I can plug in here. So when x is 0, my y is equal to 2. And when my x is equal to 3 by 2, my y becomes plugging here 2 root 2. So 6 minus root 2 into 2 root 2 by 3. So this will become 6 minus 4 as 2 by 3. Now we can use distance formula. So we know this point. So when x is 0, y is 2. When x is 2 root 2, y is 2 by 3. So therefore, length is equal to, simply by distance formula. So 2 root 2 square and then plus 2 by 3 minus 2 square. This would give me 2 root 2 square is 8 and then 2 minus 6 is minus 4 by 3 is 16 over 9. So this is 72 plus 16. So this guy wants us to take 2 common in fact. So let's take in fact 2 common here directly. So that means I need to take 4 common. So when 2 is out here, then in the square root I get, this is 2 over 3 here because I'm trying to match it here directly. So from here I'll take 4 out and from here also I'll take 4 out. So that means now I'm left with, and this 9 I've multiplied. So I'm left with basically 4 here plus This will be, oh no, incorrect. You have taken already 9 out. So let's do one more step. So 4 is out here already. This gives me 2 plus 4 by 9. So this will be simply 18 plus 4, 22. 18 plus 4, 22. So 2 by 3 square root of 22. I get. That means my alpha should be 22. Let's move to the next question. So it is given here if alpha x plus beta y is equal to 109 is the equation of chord of the ellipse whose midpoint is given. So again, the same story, even the ellipse is same, I guess. Yes, this is the favorite ellipse of J professors. Now, let's go ahead. So again, I'll use the fact that t is equal to so t is equal to s1. Then I'll be writing here my tangent with respect to this point. So I'll be having here x over 9. Then x1 is 5 over 2 plus y over 4. And then this will be 1 over 2 here is equal to s1 would be, I need to plug in this point here. So 1 over 9. And then this is 5 over 2 square plus 1 over 2, 1 over 4 into 1 over 2 square. So 1 over 4 into 1 over 2 square. We need now to simplify this equation basically. So this looks like 5x over 18 plus y over 8 is equal to, this will be 25 over 4 into 9 is 36 plus 4 into 4 is 16. So I get 1 over 16 here. So we now need to simplify this into the desired format. We need to bring 109 into the picture anyhow here. So let's go ahead. This looks like 18. That means from the denominator, I can cancel some of the things. And I'll be having 5x over 9 plus y over 4 is equal to 25 over, this is 18 plus 1 over 8. So I've cancelled them by half. Because of this 9 I couldn't. So now let's multiply. So I need now 9, 4 into 5 is 20x plus this is 9y over 36 is equal to 25 into 8 is 200 plus 18 over 8 into 18. So from 18, I'm going to cancel 2 here. And then with this 2, I'm going to cancel 4 here. And with this 4, can I cancel these things? No, I guess no. So let's go ahead. But with this 4, I can cancel half of them. So I'll be having here 100 plus 9. So yes, that means I got here 20x plus 9y is equal to 109 by 2. This 2 is pending here. So 2 I'm going to multiply here. So this is going to be 40x plus 18y is equal to 109. So this is the desired form. So alpha plus beta would be 58. This is alpha, this is beta. Coming to the next question. So we now need the equation of the chord of this ellipse whose midpoint is 3, 1. So again, t is equal to s1 concept. So t is equal to s1 means x over 25 and x1 is 3, x1 over a square plus y1 over b square is equal to x1 square over a square plus y1 square over b square. So this would give me 3x by 25 plus y over 16 is equal to 9 over 25 plus 1 over 16. I can multiply this and this gives me 48x plus 25y over 25 into 16 is equal to 16 into 9 is 144 plus 25 over 25 into 16. And politely these two guys get cancelled. And this gives me 48x plus 25y is equal to 169. And this gives me the equation of chord of the ellipse whose midpoint is this. Let's see one more. So this problem, I want you to pause the video and then try it on your own. So we want the length of the chord of the ellipse whose midpoint is 1 comma 1 over 2. And the answer you should get is 2 by 3 root 15. And if you get it, please reply me in the comment section. Thank you so much. See you in the next session.